This is example number 11 of the AEC practice test, the structural practice test. And the purpose of number 11 is to find the location of the centroidal axis and the moment of inertia of the girder shown about the centroidal axis. And we have done this on the last two videos, but we're going to go ahead and do it on this one. This one's a little bit different because it's irregular, I guess. It has, we'll call this A1. Then A2 is the web, A3 is the bottom flange. And if you didn't know, this long skinny part of an I section or a W flange section, wide flange section, is the web. And this is the flange and this is the flange. And the flanges are typically for bending or moment, or for resisting bending or moment, and this web is for resisting shear. You typically don't account for the flanges when you're talking about shear, but we'll get into that later. For right now, we're just trying to find the section properties of this section, and the two section properties we're looking for are the centroidal axis, and I think they go, in the example, they go from the top down. We'll go from the bottom up, just to show you it doesn't matter which way you go. So, as we've said before in the last couple times, the centroidal axis is the sum of the areas times the distance divided by the sum of the areas. Alright, so we'll take A1 first, and the areas of A1 times the distance. So it's 2 inches times 10 inches is your area. Your distance is, well, it's going to be 18 minus 1, so 17 inches. Or you could have said 1 plus, I'm going to go ahead and write this in. That's 16, 15. This is going to be 15 in the middle. This 18 minus 2 minus 1 is what's left over. And then we go to A2. A2 is a ½ inch times 15 inches times the distance to the centroid of this section is 1 inch plus half of 15, which half of 15 is 7.5, plus 1 is 8.5, so we have 8.5 inches. That's A2. A3 is 6 inches times 1 inch times a ½ inch is the D. The distance to the centroid of the bottom is half of 1. Or if it makes sense to you and you can better follow it, you can just, for instance, do whatever. You could write it out, 1 plus 15 plus 2 over 1. And then this would be 1 plus 15 divided by 2. And this would be 1 divided by 2. And I hope you're following my calculations there, but I'm going to assume you are. 2 inches times 10 inches, that's your area of A1. ½ inch, that's 5, times 15 inches, that's your area of A2. And 6 inches times 1 inch is your area of A3. And we're going to go ahead and do the math. And your answer is 12.14 inches. That's rounded. Well, I just cut off the rest of the figures here. I rounded it to the 2 sig figs, let's say that, if that's what it is. But anyways, we can check that, and he said his was 5.858. Oh no, we got it wrong. Just kidding. Remember, he did it from the top. So we're 12.8 is, let's say, about right there. So this is 12.14 equals. So this has got to be what? And this is what the good gentleman that put together this study guide. We can just say 18 minus 12.14 is what he should have got, which is 5.86. Is that what they got? They got 5.858, which is 5.86. Same thing. Close enough good enough for government work, and so we know we're good on this. Coming from the bottom is the same as going from the top. It just kind of is your frame of reference. Now we want to go ahead and say what is the moment of inertia. And the moment of inertia for this rectangular section is BH cubed over 12 plus AD squared. And if you remember, it's the base times the height cubed divided by 12 plus the area of the section times the distance, not diameter, the distance to the neutral axis. Remember, to the neutral axis, not from the bottom or not from the top, from the neutral axis. So let's bring it down here where we have a little bit more space, and we're going to do A1 first, and that is base is 10. Height of A is 2 cubed divided by 12 plus your area is 10 times 2. D, and this is a little bit more tricky because we have to remember it's from the neutral axis. So how far is it from the neutral axis? Well, 5.86 to the top. Well, we know, and then the center of the centroid is half of this. It's in the middle, so it's 4.86. That one was pretty quick, easy though. 4.86 inches squared. You're done with A1. Now we move on to A2. A2, the base, is a half inch. The height is 15 inches. Cubed over 12 plus AD squared. A is 1/2 times 15. Now D, we go take a look over here. What is D? Well, you can do a little thought process here. And your neutral axis, let's label it neutral axis in A. Neutral axis is up here, and you're looking at this. Let's change colors real quick. You're looking at A2 is right here. So you have to ask yourself, okay, well, where's the neutral axis of that? This beam, or not this beam, but the web part of this section, where is it? It's right in the center. We know that is the centroid. So how far away is it from the neutral axis? So halfway is 15, or half of 15 is 7.5. So we know it's 7.5 from the top, let's say, and then you can, well, actually, let's make it down here. Let's say it's 7.5. Well, you know it's 12.14 from there. And then that is 12.14 from here. That means it's 11.14 from here. And then 11.14 minus 7.5. Means the centroid is 3.64 inches from the central axis. The centroid of section A2 is 3.64 inches from the neutral axis. Which, go over that a few times, make it sure you understand what we're doing there. And we'll come down here and say for unit 3, or A3, let's call it A3, area 3, is base times height, base times height of 1 cubed over 12 plus area is 6 inches times 1 inch times distance. So we already know that this is what? 12.4 from here, from the neutral axis to here. So that'd be 12.4. You can just write it out like this. 12.14 minus 1 inch divided, not by 12, that's stupid, divided by 2. Or 12.14 minus ½ inch, that's squared. Let's go ahead and do the calculation on that. And the answer is 1,532.5, let's say, inches to the fourth. And if you need to convince yourself that those units are correct, you just go ahead and say Well, I got inches squared, so squared inches, inches to the third, inches to the fourth. And that's for the AD squared, and you can also say for the BH cubed part, say inches plus inches to the third is inches to the fourth. There you go. We'll go ahead and check this. And 1532.2. I had 1332.5, but that is close enough. Just rounding. That answer matches up, and we are good. Your two answers equals I. And your centroid, or neutral axis of this section, is 12.14 from the base here.